Dear students, so today we will talk about chapter number 6, which is related to the big data processing concept. So we will discuss that how the big data processes are working and how it can be simulated. So in this one, we can see that usually the big data has three main problems as volume, velocity, and veracity. So as the volume is considered, we need to divide the different tasks with respect to the different processes. So we divide the task into three sections like A, B, C, and assign it to the three different processes like A, B, and C. So you can see that a task is divided into three subtasks which are executed in parallel and on different processors, means computers or within the same machines, right? So it means when I say processors, means like it could be processes inside a one computer or it could be processed in a multiple computers. So this is one of the classic example of distributed data processing, that how the distributed data processing is being done over there. So one single task is divided into many tasks, okay, like A, B, C, and it is then assigned to different computers like physical server A, physical server B, or physical server C, and these three are then combined and then it's returned to a specific physical switch over there. In the figure 6.3, you will see a very interesting structure for Hadoop, which is a versatile framework that provides both processing and storage capabilities. So on the left-hand side, we can see that there are three different kinds of the data. One is unstructured, totally unstructured data like textual data. Second is a structured data like SQL tables data. And third is a semi-structured data, which is a XML data. So these three data has been like processed by Hadoop. So Hadoop has a capability not only to process but to store both. So this is one of the unique quality of Hadoop, which is developed by the Google. And then from when after it has processed the data and the processing has been done, so it is then the data is shifted towards the reports application and then one can analyze as well towards the analytics. Now we can see that we have different operations in the database SQL, like we can insert, select, update, delete, right? So these are the different operations, and these operations can be done one by one, or it could be done into a batch workload, can also be grouped together, and it can be done as well. Since we have then a transactional workload have a few joins, if you see the transactional law, so it has a very few joins and they have a low latency. Latency means the delay responses than the batch workloads. And then we see here in this figure 6.6, we see a cluster which is utilized to support batch processing of the bulk data and real-time processing of the streamline. So you can see over here we have a streamline data, which could be an image. Okay, then we have like batch data, which could be the combinations of JSON file, XML file, and then this has been processed. And after the process, then it could be visualized in a kind of a dashboard. This is a very typical symbol for a processing engine. So those who are dealing with the big data concepts and big data processing or big data paradigm, so they are aware of this sign, and this sign is particularly designed for processing engine. Now we see an illustration of the MapReduce job with the map stage highlighted, that how MapReduce works in Hadoop. So you can see over here, first the mapping is done for the different tasks, okay, and then it is combined, and after that it has been partitioned. So after partitioning, the step is for the shuffling and the sorting. So shuffling and sorting is done, and then when they are common, so it has been reduced towards it. So we'll see that what are the common things and how can we reduce it in the next upcoming slide. There's a very interesting and popular concept in the map reduce, and that is called the key value, right? So sometime we store the data, whether it's a structured, unstructured, and semi-structured, in a single record, right? And then that record is termed as that record is assigned a value which is called a key value, right? So these key values are like stored for different kinds of the data, and the listing is being done with respectively. So you can see the combined stage group that the output from the map stage. So this is like continuation of the previous one, and it can be seen that before we did in the previous one we did mapping here, okay, and in this one with the help of the key value we did the combinations of these items. And after the summary of the combined stage, so we shift towards the next stage. But before going to this next stage, we have some important information related to the 6.12. So it tells that the partition stage assigns output from the map task to the reducer. So it means that like 5 billion DVDs is equal to, like, 2.5 exabytes, right? And this 65,000 DVD is equal to 300 terabytes. So this means that the data has been reduced from 5 billion DVDs to the 65,000 DVDs. So this is one of the magic for the map reduce, that which does it for the data. Now we can see here the summary of the partition stage, that how they summarize it. So usually the key and value is then indexed, and after the index, the summary of the shuffle and sort is being done, and mathematically it is shown in the figure as seen in the slide. And the next stage is during the shuffle and sort stage. What is done, the data is copied across the network to the reducer nodes and sorted by the key as well. So we have the key, so key is used for indexing and the sorting. And in 6.16, it's a continuation of the previous one, and it also give us the idea that the reduce stage is the last stage of the reduce task. Okay, so after the reduce is done, then we stop here. And it's a summary of the reduced stage. So how we represent in a mathematical way. So we represent in a parenthesis way, and we can say that the next key value is shifted to, for example, key 2 to the k3. Okay, this is a very interesting example, and it will clarify all the concepts of MapReduce, that how it works. So if we look over here in this one, I would just like to highlight some of the things. For example, we have some items, for example, sales, chai, let's suppose, sauce, okay, tofu, and then chai, and then tofu, right? Okay. So this is split one. Let's suppose the data has been done in split one, and this is the split two. We have it, right? So this one is done in the node A, okay, and this is on the node B, right? Okay, so now what we do it, we start counting that how many chai are there. So there are 3 chai, okay, and we have 5 sauces, okay, and then we have 8 tofus and 9 chai and 1 tofu. So what we do now, we start from the this text file. This is the sales.txt file. This the data is in it. Then we map it. So in the map we just copy paste the item, and then we combine it. So how we combine it, we just count how many chai are there. So it's 3 and 9, so total is 12 chai. We have it. Sauce is 5, we have it here, and the tofu is 9. So you can just count it down, okay, and then we do partition. So partition after that one, and similarly with this case as well, here we just copy it from the text file, we map it, right, and then we count it. And so the number of sauces, how many total number of sauces. So now this has been combined, and this one now we have, this is for A part, some part of the file, and some part of the file for B, and then we combine it, right? So after it has been combined, right, then we can write in a form of what, in a form of a order pair. So this is called order pair in this parenthesis, okay, this is called order pair, and we write it in from the node A in the first beginning, and the node B in the second order. And similarly we write it for the sauces and the tofu, right? And after that one, what we do it, we then add them up, just common. Let's, for example, 12 plus 7 is 19, and 5 plus 9 is 14, and 9 plus 7 is 15. So this is the final, the shuffling has been done. So you see the shuffle and sorting has been done. We have shuffled these two one, we have sorted this one, right? Okay, and now we have the we have all the output in the map reduce. So so this, I hope you understand this concept now, that how the map reduce works. This is like further elaboration, that some task has been a task is split it into two subtasks, like task A and task B, which are then run on two different nodes on the same data set, right? So this is elaboration that how how different records would can be seen the same record but in a different computers. Now, data set is divided into two subsets. Now you can see over here, here the data is different, right? In the previous one, you can see over here, some part of the database is here and some part is here, right? So this is 1 and 2 and 3 and 4, right? So this is different. But in the previous one, if you look, if you go back, so it's the same data, it's replicated. Okay, now you see over here, for example, this is an instance, it's like, one example that where the three lines constitute a single record. You can see over here, you have the address 1, address 2, and zip line, and it gives you the full address. Okay, then we have a very interesting diagram which is called SCV. So SCV is like, for speed of the data, like consistency means no correction of the data, and consistent data, and then volume, right? So these are like, sometimes this Venn diagram, it tells you that where are like, coincidence and where are the non-coincidence values. And then we have so here is an example of a real-time data processing in a big data environment. So we can see that the streaming data is input into it into the data transfer engine, and after that one it goes into the in-memory storage device. Okay, so this is the signal. This is the diagram for the in-memory storage device, and after it has been processed, then it goes to the dashboard, means like a visualization. Okay, and you can fetch the data from the storage device. So usually the in computer sciences the data is is fetched from the storage devices, and it is like, fetched into the memory, which is the RAM. So this is basically RAM, okay, random access memory, RAM, and this is your storage, okay, hard drive. Okay, so thank you very much and see you in the next class.